Hey guys, so this is your homework from last night, and for each problem you have to do three things. You have to define your variables, you have to write a system of inequalities to represent the constraints, and then you have to write the objective function. So last night you did not have to do the last part, which is graphing and finding the solution. So we are going to go over the first three parts together for each problem. And then for the rest of class and for your homework, you're going to do the last two parts. You're going to graph and you're going to find the optimal solution. So if you were very confused on your homework last night, I should at least expect everybody to be able to do the first part. Identify the variables. What are they asking you to figure out? What does my x and y represent? So in this case, it's asking you to find the number of mowing jobs and the number of pruning jobs that will maximize the income. So how many mowing jobs should we do, and how many number of pruning jobs we should do in order to gain the most amount of income for the company. So I'm going to let x represent the number of mowing jobs. And I'm going to let y represent the number of pruning jobs. So that's always step number one. And then you're going to use x and y to come up with your constraints. So what are my limitations in this problem? So your constraints, let's see what we're limited by. It says we only have a maximum of 9 hours a day. Okay, so we only got 9 hours, and it takes 1 hour for a mowing job and 3 hours for a pruning job. So if you have colorful pens or highlighters, you can start underlining in different colors so that you can underline the same constraints in one color and help you organize the information. So my first constraint is going to be about hours. My first limitation is about hours. So 1 hour, I'm going to spend 1 hour for every mowing job times however many of those we do, plus the time we spent for prunings would be 3 hours for one job times however many of those we do, has to be a maximum of 9 hours. So it could be less than 9 hours or exactly equal to 9 hours, but not more. So that's my first constraint. Another constraint is that each crew is scheduled for no more than 2 pruning jobs per day. So no more than 2 pruning jobs a day. So this is a constraint that concerns y, the number of pruning jobs. It's got nothing to do with x, right? So the number of pruning jobs, y, can be no more than 2. So it has to be less than 2 or exactly equal to 2. So those are our 2 constraints. Now the only thing I would add here are my 2 common sense constraints. Remember, it doesn't make sense to have negative number of mowing jobs and negative number of pruning jobs. So I'm going to add in my common sense constraints. And then let's figure out what our objective is. What's our goal here? So they're asking us to figure out how many mowing jobs and pruning jobs we should do in order to maximize income. So our objective, our goal here, is to maximize income. And so we have to come up with a rule to calculate, well, how am I going to figure out how much money I take in? So we're going to write a rule for income. And income can be calculated by, so it looks like we're going to make $40 for a mowing job, and we're going to make $120 for a pruning job. So the income is going to be $40 times however many lawns we mow, plus $120 for each pruning job times however many of those we do. All right, the only thing we have to do here is write our objective function, our rule, in function notation. So it could be, we replace the word income with the mathematical notation f of x comma y if you want, because the function depends on x and y. So instead of just f of x, we're going to put f of x comma y. Or because it's income, instead of f, we could use I. It doesn't matter. So I'm going to use I, and I'm going to say my function for income, I, depends on x and y, and this is how you calculate it. 40x plus 120y. So later on in class, after we go through the homework, you guys are going to work on each problem, and for each problem you're going to do the last two parts. So you're going to graph the constraints. On your graph, you're going to shade the feasible region. You might have to rearrange the first inequality to slope-intercept form. Graph, shade, and then once you shade, remember that represents, the shaded region represents all the possible solutions. And we want to see which one will make the most amount of money for me by testing it into this equation. But remember yesterday or last class, we had said that instead of testing every single point, which would be a lot to do, the vertex principle says we only have to test the vertices. The maximum and minimum, the best solution is going to occur at one of the vertices, one of the corner points. So once you graph, you identify what the corner points are, write it down, and then you test it into this objective function and see which one, which option, which combination of mowing and pruning jobs gives you the most income. So you're going to do that for every problem. Let's look at number 2. Okay, so it says a potter wants to make and sell serving bowls and plates, and it's asking you how many of each should he make in order to maximize income. So the question that they're asking us, that's our x and y, is how many bowls and how many plates should he make, right? So that will be our variables. Number of bowls and number of plates. Okay, so then let's look at our restrictions, our constraints. We have, looks like one constraint, one restriction is that we only have 40 pounds of clay. So it looks like we only have 40 pounds of clay, and it takes 5 pounds of clay to make one bowl and 4 pounds of clay to make one plate. So one inequality that we can come up with would be for the amount of clay that we have. So that would be 5 pounds for every bowl plus 4 pounds for every plate. Has to be less than or exactly equal to 40 pounds because we don't have any more than that. And then another constraint is the potter wants to make at least 4 bowls since he already has customers who want it. So this has nothing to do with y, plates, it's just x. The number of bowls, x, has to be at least 4. So it could be more than 4 or exactly equal to 4. Okay, and then those are our 2 constraints. And then let's add in the common sense constraints. I'm going to add in y has to also be greater than or equal to 0 because we can't have negative number of plates. And this one though, x is greater than or equal to 0, I don't really have to add in because I already have this. If I'm saying that x is greater than or equal to 4, well, it's obviously going to be greater than or equal to 0, right? So we don't have to add in that second one. And let's look at our objective. Our goal here is again to maximize income. Our objective is to maximize income. And we have to come up with a rule, a function to help us calculate how much income he's going to take in. So in function notation, I'm going to call I for income. The function for income depends on X and Y, and it can be calculated by, looks like he's going to make $35 for each bowl and $30 for each plate. So that would be 35X plus 30Y. Okay. Now, when you're doing this on your own, if you had put Y as number of bowls and X as number of plates, that's okay. It's just that your X and Y would be swapped from mine in these inequalities and equations. Okay, let's look at the next one, number 3. Now we have a company manufactures 2 types of printers, inkjet and laser printers. Okay, and the question, identify your variable. The question is, how many of each should we make? How many inkjet and how many laser printers we should make? So I'm going to let X equal the number of inkjet and Y equals the number of laser printers. Okay, so now again, let's figure out what we are restricted by. What are our constraints? Okay, so it says the first one looks like the company can make no more than 60 total printers a day. Company cannot make more than 60 printers. So the total number of printers, that would be all the inkjet printers, X, plus all the laser printers, Y, has to be no more than 60, less than or equal to 60. Okay, and then another constraint would be the amount of time that we have. It says there is 120 hours of labor per day that's available to us. And it takes 1 hour to make an inkjet and 3 hours to make a laser printer. So, and then a constraint regarding time would be 1x plus 3 hours for one laser times however many laser printers we make has to be less than or equal to 120, because that's all the time that we've got. Okay, and then let's just add in our common sense constraints. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. Doesn't make sense to have negative number of printers. And then our objective. Our goal here is to maximize profit. So our objective is to maximize profit, get the most amount of money, and so we have to come up with a rule, a function to calculate how much money we're going to take in. So I'm going to call this function P for profit. The profit function depends on X and Y, so P of X and Y can be calculated by, looks like we're going to make $40 for an inkjet printer and $60 for a laser printer. So the profit is going to be 40x plus 60y. Right? And then this is the rule that you're going to test your corner points into. So you're going to graph, you're going to find the corner points, the vertices, however many there are, and you're going to test each one into the objective function and see which one gives you the most profit. Right, number 4. Now we have Mr. Jones, who is making corn muffins and bran muffins. Okay, and the question is, how many trays of each should she bake? How many trays of bran muffins and corn muffins? So X is going to represent the number of trays. How many trays, right? Number of trays of corn muffins. And Y is going to represent the number of trays of bran muffins. And as you're watching this video, now that we've gone over 3, it might be helpful for you to pause right here and see if you can figure out the constraints based on what we did in problem number 1, 2, 3. See if you can do it on your own, and then check, skip forward and check to see if you got it correctly. And if you didn't, then you can rewind and see how I figured them out. All right, and then if you did, then you move on to the next problem. That way you get practice on coming up with the constraints and the objective function. So go ahead and pause the video, see if you can come up with the constraints, the objective function, and then check. So it looks like one thing that I'm limited by is that I only have 16 cups of milk. Right, we only have 16 cups of milk. And it looks like corn muffins takes 4 cups of milk, and bran muffins takes 2 cups of milk per tray. So our first constraint is going to be the amount of milk that we have. So that would be 4 cups times however many trays of corn muffins plus 2 cups times however many trays of bran muffins has to be less than or equal to 16. And then another constraint would be that we only have 15 cups of flour. Okay, so looks like corn muffins takes up 3 cups of flour and bran muffins take up 3 cups of flour as well. So we have 3x plus 3y has to be less than or equal to 15. And then we're going to add in our common sense constraints. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. And then our objective, our goal is to figure out how many trays we should make in order to make the most amount of money. Okay, so again, our objective is profit. So I'm going to say P of XY is equal to, looks like she's going to make $4.50 for each tray of corn muffin and $3.25 bran muffins give her $4.50 and corn muffins give her $3.25. So that would be $3.25 times however many trays of corn muffins she sells, plus $4.50 times however many trays of bran muffin she sells. That would be her total profit. And again, this is the rule that you're going to use to test your possible solutions into, so to see which one is the best option. Okay, number 5. Again, why don't you pause the video for a minute and see if you can figure out the variables, the constraints, and the objective function, and then skip forward in the video and check to see if you got it right. And then if you did, you move on. If not, you rewind and check. So we have Mr. Greenstein, who owns a parking lot, and the question that they're asking is, we have buses and cars that park there. How many vehicles of each type should be parked to realize the most profit for Mr. Greenstein? So let X equal the number of cars and Y equals number of buses. If you did it the other way around, that's okay. your inequalities, the x and y in your inequalities would just be reverse of mine. All right, so first constraint looks like that there are only 600 square meters of space. So we only have so much space available. And it looks like each car takes up 6 square meters of space, and each bus takes up 30 square meters of space. So the first constraint is about the amount of space. So that would be 6 square meters times however many cars there are, plus 30 square meters times however many buses there are, needs to be less than or exactly equal to 600 square meters, because that's all we got. Can't go over. Second constraint, looks like the attendant who parks the vehicle can handle no more than 60 total vehicles a day. So I can only have 60 cars a day, or buses. So x plus y, number of cars and buses, total vehicles, has to be less than or equal to 60. Okay, and then we're going to add in our common sense constraints. Doesn't make sense to have negative number of buses and cars, so x and y has to be greater than or equal to 0. So our goal again is to maximize profit, make the most amount of money. So objective is to maximize. Actually, it's asking you two questions, right? It says how many vehicles of each should be parked to realize the most profit and the least. So it's asking you to maximize profit. What is the most? The option that will give me the most amount of money, and also minimize profit. What is the option that will give me the least amount of money? And both of those answers are going to be one of the corner points. When you graph the inequalities and you shade, you pick the corner points, the vertices, to test into the objective function. And one of the vertices is going to give you the maximum, and the other one is going to give you the minimum. So our profit function, P of xy, is going to equal, looks like it charges $10.50 for each bus, $10.50 for each car, and $25 for each bus. So that's going to be $10.50 x plus 25y. And then last one, number 6. Alright, so we've got a clock manufacturer in Plymouth who makes 2 types of wooden clocks. He makes clocks that are pine and clocks that are oak. So the question they're asking us is, how many of each type should he make in order to maximize profit? So x and y, x is going to represent the number of pine clocks, and y is going to represent the number of oak clocks. Okay, let's see what our constraints are. What are we limited by or restricted by, criteria that we have to fulfill? It looks like it takes him 2 hours to assemble either kinds of clocks. So 2 hours to make a pine and oak clock, and he has 20 hours that he can spend each week doing that work. I'm on the second sentence. So it looks like one constraint is that he only has 20 hours, and each clock takes him 2 hours to assemble. So first constraint, 2 hours for each pine clock plus 2 hours for each oak clock has to be a total of less than or equal to 20 hours, because that's all the time he has. Second inequality, he has 16 ounces of varnish to coat his clocks, and each pine clock requires 1 ounce, and each oak clock requires 2 ounces. So 1x plus 2y, or just x plus y, has to be less than or equal to 16 ounces. And then adding in my common sense constraints. Can't have negative number of clocks, so x and y has to both be greater than or equal to 0. And then my objective is to maximize profit again. Usually that's the objective, that's the goal, make money. Sometimes it's minimizing costs. So P of XY, the profit that he's going to make, can be calculated by, looks like he makes $25 for an oak clock and $35 for a pine clock. So 35x plus 25y. If you wrote 25y plus 25y first plus 35x, that's okay as well. And so this is my objective function. Okay, so now for the rest of class and for your homework, I want you to go through all 6 problems again. I want you to graph the inequalities for each problem on the graph. Label your graph. As you're scaling your graph, sometimes you could go up by 1, right? You have enough space to go each unit go up by 1, and you can label it. Sometimes you have to go up by 5 or 10s in order to fit it on your whole graph. So an example like this, you might have to scale by 5 or 10. So you can scale any way you like. I would recommend scaling your x's and your y, your x-axis and your y-axis the same way, so that when you do your slope, it's easy to count the spaces. But for each inequality, rearrange into slope-intercept form, graph, and then shade, and find the feasible region. That would be the shaded region that represents all possible combinations of solutions that work for this problem. And then instead of testing every single point, remember you only have to test the corner points, all the vertices. Sometimes there may be 3, sometimes there may be 4. So you're going to test each vertex into this objective function and see which one gives you the most profit or the most income. And then once you figure it out, answer the question that they're asking you in a complete sentence, right? Don't give me just a point. 3, 2. What does that mean? 3 oak clocks, 5 pine clocks, whatever that may mean. So answer the question. And that will be what you're going to work on for the rest of class and for your homework.